In this little video, we will be talking about species accumulation and rarefaction curves. The two are related, and I will explain here how they are related to one another. Imagine you're going out into the field and you're counting or recording the species that you are finding there. As you go into the field, you record the first individual and it's species A. So the individual is just in the individual column, the species identity in the species column here. The second individual is species B, the third individual is species B, the fourth individual is species C, etc. Once you've set up these two first columns, you can then record how many species you have recorded at every individual. So of course, after you've recorded the first individual, you have only counted one species. After you've recorded the second individual, you've counted two species, namely species A and B. After the third individual, you have still only counted two species, namely species A and B, etc. And so we can carry on. So we use this information from the first column and the third column to create a species accumulation curve. On the x-axis, we have the individual, so that's just the individual organism that we are recording, so the first, second, third plant or animal or whatever we're dealing with. On the y-axis, we have the number of species as we go along. However, the species accumulation curve is influenced by by the order in which we are recording species. So, for example, in the very same community with the same individuals, we may have recorded species A much later. So our table could have looked like this. In this particular case, the first two species that we recorded were species B, and then the third individual that we recorded was species A. So the numbers of species recorded are now slightly different, and as a result, our species accumulation curve also looks slightly different. Right, and I've done another example, so I've just shuffled the species column and created this table. So we still have the same number of individuals of each species. So for example, we've still got three individuals of species B here. And I've just created another species accumulation curve, which looks like this. Okay, so here are three examples of what the species accumulation curve for the same community can look like. All I've done is I've changed the order in which we've recorded the individuals. And there are many more possible species accumulation curves. What you will notice is that all the species accumulation curves stop on the same point, namely at 5 species. The reason for that is that no matter the order in which we have this species column, we always end up with the same number of species in the community. We always have 5 species because we've got the same individuals. All we've changed is the order. This now is where the rarefaction curve comes in. As I've said, there are many different options of what the species accumulation curves can look like, and the rarefaction curve is basically an average of the species, of all options of the species accumulation curves. So it's created by creating random orders in which the individuals in the community are picked. Okay, so basically the rarefaction curve is an average of all possible species accumulation curves. And you can still see that it ends on 5 species. So we can use the rarefaction curve for two purposes. The first purpose is to estimate how many species are really in the community. Remember that when we go into a community, we hardly ever record all different species in the community. We will record many, hopefully, of the species, but we may miss a species or two particularly rare species. So the way that we can estimate the total number of species in a community using a rarefaction curve is by extrapolating this curve. Right, the curve can be described by a mathematical function, and it has an asymptote. The asymptote is just the value that it approaches, and we can use that asymptote as an estimate of the total number of species in that community. The second thing that we can use the rarefaction curve for is to determine how extensively we have sampled the species in the community. And this we do by looking at the shape of the rarefaction curve. This particular rarefaction curve, so the black curve, indicates that we have sampled some species, a fair number of species, but we are probably missing a number of species that we haven't sampled. And the reason that we conclude this is because the rarefaction curve has not started to flatten off. So if we were to extrapolate the curve, it would probably increase quite a bit more as we went from left to right. This is opposed to if our rarefaction curve looked something like this. If it looked like this, then we could have more confidence that we have actually sampled most of the species in the community.